Greetings, fellow hobbyists. Citizen Shane here with another installment of what I like to call the Layman's Lecture Series. This is where I talk about stuff that I don't really have any expertise in, but I find interesting, and hopefully you do too. I had kind of what could be an epiphany earlier today, and it has to do with the concept of the principle of uncertainty and also the laws of thermodynamics. And it happened because I was trying to measure the amount of RAM that I had available on my computer. Now, if you look behind me, you can see that my task manager on my computer, it shows that I have a certain amount of available RAM and I have a certain amount of free RAM, which is the RAM that's not being used. The available RAM is how much I actually have installed on my computer, so that's the maximum. I would like to do a calculation to find out how much is actually being used. So it would be a simple calculation, right? You subtract the available from the free, and that will tell you how much is being used. Only problem is, and this is where the second law of thermodynamics comes in, if I try to use the calculator that's built in on my computer to do this calculation, what you'll actually see is the amount of RAM being used increases because calculator is an application on the computer that's now being used. So that's a real world example of how in a closed system, and I think that's part of what's responsible for the uncertainty principle phenomenon, because the computer is a closed system, by using a part of that system, the calculator application, to try and measure another part of the system, I'm actually changing the results by measuring them, which is, a fundamental issue you run into in most fields of quantum mechanics. The reason I think this is interesting is because there must be a way, right? If that's true, based on that logic, there must be a way for the momentum and the position we measured. That's the uncertainty principle. You can't measure the momentum and the position of a particle at the same time, because by measuring that, you're actually kind of changing the mechanics of what's going on. That's why they call it quantum mechanics, because something's always broken and we measure it, and you need to call a quantum mechanic to come fix it. Anyway, they just make things worse and find ways to charge you more for stuff that isn't broken in the first place. So I think the reason the uncertainty principle exists, or at least we're experiencing it, the reason it exists for us here, is because we're in a closed system. If there is a way to transcend that closed system, there'd have to be a way for us to measure the position and the momentum of a particle, given us being outside of that closed system. So this may be kind of a bridge, because these two sides are always fighting with each other. This may be kind of a bridge between, the subatomic world of physics and the practical, self-evident sort of Newtonian world of physics, which are always at each other's throats, kind of like politics. When I talk about, give my politics lecture, one thing you might hear me say is that there's extreme rhetoric on both sides, but usually the truth is somewhere in the middle. And you might be wondering why I'm wearing this really cool t-shirt today. It's not because I happen to look like Jesse Pinkman a little bit because of my beard. It's because the guy who came up with the uncertainty principle, his name was Werner Heisenberg. Something to think about.